Welcome to the Explainer. Today we're doing something really cool. We are decoding the covert arts of data concealment. We're going to pull back the curtain on how sensitive information is truly protected in our modern digital landscape. We'll be looking at the actual methods used to make data confusing, completely invisible, or just entirely fake to unauthorized eyes. It's a really fascinating journey into what is basically a digital spy toolkit, one that secures everything from massive global networks right down to the smartphone sitting in your pocket right now.
Okay, let's dive right into this. Seriously, I want you to imagine you're watching your absolute favorite streamed show. But hidden inside the very pixels and frames of that video is a secret message. It's completely invisible to you, but perfectly clear to someone who has the right key. What if at least 5% of all the streaming videos you watch on the internet actually contained hidden secret data? I know it sounds totally like science fiction, right? But by the end of this explainer, you're going to understand exactly how this is a digital reality.
So here is our mission briefing for today. We're covering the art of hiding data, steganography, hiding data in media, tokenization, and finally, data masking. Let's get to it.
All right, Section 1, the art of hiding data.
Usually when we think about security, we think purely in terms of standard encryption. But sometimes you need an entirely different approach. And that brings us to obfuscation. Think of it this way. If standard cryptography is like locking your valuable documents inside a heavy, impenetrable steel safe, obfuscation is like writing those documents in invisible ink. Obfuscation actually alters or disguises the original data to prevent it from being easily understood. The main objective here isn't just to lock it up, but to make it confusing, unclear, or just completely unintelligible. It adds this absolutely crucial extra layer of security, making it incredibly challenging for anyone to decipher without the exact proper tools or knowledge. And that is vital when encryption alone simply might not be enough for your specific use case.
Moving on to Section 2, steganography, secrets in plain sight.
This is such a brilliant transition from merely confusing an attacker to actively concealing things and deceiving them. It's actually a super ancient practice, yet entirely modern in how we execute it digitally today. To really anchor this in our minds, let's look at the etymology for a second. Steganography comes from two Greek roots. First, we have steganos, which means hidden or covered, and then graph, which means to write. Put them together, and what do you get? Hidden writing. It's basically a form of covert communication where you hide a secret message inside or even right on top of something that isn't secret at all.
So what's the actual difference here? This perfectly illustrates the core distinction between these two major security concepts. Cryptography takes a message and scrambles it using a mathematical key, right? You can physically see the scrambled message, you just can't read it. But steganography, it doesn't use scrambling, and it doesn't necessarily use a key in that same way. Instead, its entire purpose is to conceal the very existence of the secret message. The attacker doesn't even know there's a code to crack because the data is just hiding out inside a totally normal, non-secret medium.
Now, what's really interesting about this is that these modern steganography tools aren't just some theoretical concept. The Kali Linux distribution, which is a massive favorite in the cybersecurity world, actually includes a number of these tools right out of the box. We're talking about apps like StegHide, Foremost, Zhao, Stegice, and Concealment, and they are actively used today. And here's the kicker, they're used by both sides. Hackers use them to sneak malicious scripts or stolen data right past firewalls, and IT professionals use those exact same tools to detect, uncover, and analyze that hidden data.
Section 3, hiding data in media. This is where we get to look at exactly how different types of multimedia are used as the everyday carriers for these covert, invisible communications. Let's start with audio steganography. It's almost like a math equation. You take a normal audio file, that's your carrier or your cover file. Then you add your secret message, which could be text, an image, or even another file entirely. You encode it with a password, and boom, you get a stego file. What's absolutely amazing about this is that the audio sounds exactly the same before and after. Tools like Deep Sound modify the audio signal so subtly it's imperceptible. And newer tools even let you encrypt the secret files using military-grade AES-256 encryption before you even hide them. That adds massive data protection right inside the host message itself. Now, when we look at image steganography, things get pretty deep into the technical weeds. There are three highly effective methods to know about. First is least significant bit, or LSB substitution. This literally iterates through image pixels, extracts the alpha, red, green, and blue hex values, and then swaps out the very last, least significant bit of that color data with the binary data of the secret message. Second, we have blocking. This breaks the image into blocks using 64 discrete cosine transform coefficients, which basically approximate luminance and color and modifies them to hide messages. And finally, palette modification. This one simply replaces completely unused colors in an image's color palette with colors that secretly represent the hidden data.
And wow, that brings us right back to our hook from the beginning of this explainer, video steganography. Because think about it, a video is really just a massive collection of individual image frames, right? That makes it an incredibly secure medium due to its sheer size and complexity. You can actually use free open-source tools like OpenCV to extract every single frame, store your hidden data inside those frames using that least significant bit method we just talked about, and then use FFmpeg to stitch the whole thing back together with the audio. Millions of frames holding fragments of a secret just streamed right across the internet. No one is the wiser.
Section 4. Tokenization, the ultimate decoy. Okay, let's move to and see how this builds. If steganography is for covert communication, tokenization is our enterprise-level decoy tactic. It's primarily used for protecting massive amounts of sensitive data sitting at rest in corporate databases. Think of it kind of like a coat check at a really fancy restaurant. Step 1, you hand over your very valuable, real coat, that's the original sensitive data, and it gets locked away securely in a back room, the token vault. Step 2, the attendant gives you a small, random plastic token with a number on it. Step 3, you carry that token around the restaurant. The token itself, it isn't warm, it isn't made of wool, it's just a totally meaningless substitute. But when you need your coat back, the internal system cross-references that index instantly, retrieving the real value for authorization behind the scenes completely seamlessly to you. Outside of the system, a token has no value. It is just meaningless data. That quote right there captures the absolute genius of the entire system. Look, with encryption, there's always an algorithm and a key. If a hacker gets the key, well, they get the data. But with tokens, there is literally zero mathematical relationship to the real data they represent. No key in the world can reverse a token back into a credit card number. If a hacker breaches the database and steals 1 million tokens, it's exactly like stealing 1 million plastic coat check tags but never actually finding the room where the coats are locked up. It's completely useless to them.
Just to ground this abstract concept in everyday reality for a second, this high-level cybersecurity is literally sitting in your pocket right now. Apple Pay uses a very similar tokenization technology. When you tap your phone to pay, the merchant system never, ever receives your actual credit card number. They just receive a token. But to make it useful for you, the token is cleverly designed to preserve just the last 4 digits of your card so they can be printed on your receipt alongside a bunch of asterisks. So the merchant gets paid via the secure token, you get a receipt you can easily recognize. And your real data? It never actually changes hands.
And finally, Section 5, data masking, faking it securely.
So the crucial point is how organizations handle data when they actually need to use it internally. This is a critical obfuscation technique used to protect personally identifiable information, or PII. Organizations often need to use real-world databases for software testing or running analytics, right? But they obviously can't expose actual customer data to developers or testers. Enter data masking. It substitutes the original, sensitive data, like a real social security number or a real credit card, with masked data. It essentially replaces it with an authentic-looking but entirely fake substituted number. The data format remains perfectly intact, so the software still functions normally, but the commercially sensitive data is completely obfuscated from unauthorized users and attackers. It's brilliant.
Well, we've explored the hidden depths of the digital spy toolkit today. From data cleverly hidden in the least significant bits of audio and video files, to totally meaningless token decoys protecting our financial lives, all the way to masked data faking out attackers. So, it leaves us with one slightly paranoid, but honestly highly necessary question to think about. If invisible pixels, digital decoys, and masked data are actively securing our world, what unseen data is hiding in your digital footprint right now? Stay curious, stay secure, and keep exploring the hidden layers of our digital world. Catch you next time.